Here we have x is equal to 2at square and y is equal to at raised to 4. Basically x and y both are depend on t. So let's differentiate with respect to t. So on left hand side we will get dx by dt. On right hand side we don't have to worry about 2a. We just have to differentiate t square. So basically differentiation of t square is simply 2t. So we'll get dx by dt is equal to 4at. Then same thing we have to do with the equation of y. Let's differentiate with respect to t. So we'll get dy by dt is equal to a differentiation of t raised to 4, which is equal to a 4 into t raised to 3. So we'll get dy by dt is equal to 4at cube. Now to get dy by dx, we just have to take the ratio of dy by dt and dx by dt. So your dy by dt is simply 4at cube and dx by dt is simply 4at. So 4a, 1 power of t will cancel out and we will get dy by dx is equal to t square. Ta-da! This is your answer. Here we have x is equal to a cos theta and y is equal to b cos theta. So let's differentiate both equations with respect to theta. So from equation of x we will get dx by d theta is equal to a differentiation of cos theta will be minus sin theta, and from the equation of y we will get dy by d theta is equal to b as it is differentiation of cos theta is minus sin theta. To get dy by dx we just have to take the ratio of dy by d theta in the numerator upon dx by d theta in the denominator. Minus sin theta will cancel out. We simply get dy by dx is equal to b by a. Ta-da! This is your final answer. Here we have x is equal to sin t and y cos 2t. So we have to differentiate both equations with respect to t. From equation of x we will get dx upon dt is equal to differentiation of sin t cos t. Similarly, from equation of y, dy by dt is equal to minus sin box into coefficient of t, which is 2. To get dy upon dx, just take the ratio of dy by dt and dx by dt. So in numerator you have to put dy by dt upon your dx by dt in the denominator. You can accept this as your final answer, but if you want to further simplify, we can rewrite sin 2t as a 2 sin t cos t into 2 upon cos t will be as it is. Now this cos t will cancel out and we will get dy by dx is equal to minus 4 sin t as your final answer. Ta-da! Here we have x is equal to at and y is equal to 4 by t. So x and y both are dependent on t. So let's differentiate both equations with respect to t. So from equation of x, dx by dt is equal to a will be as it is, differentiation of t will be 1. And from equation of y, we will get dy by dt. 4 will be as it is, differentiation of 1 by t is minus 1 t raised to minus 1 minus 2. Or we can say minus 4 upon t square. Now we are ready for dy by dx. In numerator we will get dy by dt. Let's get it over here, upon your dx by dt, which is your a. So finally we will get dy by dx is equal to minus 4 upon at square. Ta-da! Here we have x is equal to cos theta minus cos 2 theta and y is equal to sin theta minus sin 2 theta. X and y both are function of theta. So we have to differentiate both function with respect to theta. So from equation of x we will get dx by d theta. Differentiation of cos theta is minus sin theta, and differentiation of cos 2 theta will be minus sin 2 theta into coefficient of our variable, which is 2. So here we'll get minus minus become plus. We have to write down 2 sin 2 theta minus sin theta. Now from equation of y we will get dy by d theta. Sin theta will be cos theta, and differentiation of sin 2 theta will be cos 2 theta into coefficient of our variable, which is 2, which is equal to cos theta minus 2 cos 2 theta. Now we are ready to get dy by dx. In numerator we have to put dy by d theta. So let's put it over here, upon your dx by d theta will go in denominator. So ta-da! You can accept this as your final answer. Here we have x is equal to a theta minus sin theta and y is equal to a 1 plus cos theta. Both are function of theta. So let's differentiate both equation with respect to theta. From equation of x we will get dx by d theta. A will be is different, theta will be 1 minus differentiation sin theta will be cos theta. And from equation of y we will get dy by d theta is equal to a as it is, differentiation of 1 is 0, and differentiation of cos theta is minus sin theta. So we will get minus a sin theta. So we are ready to get dy by dx. Your dy by d theta have to put in numerator upon your dx by d theta will move in denominator. So a will cancel out. We will get minus sin theta upon 1 plus cos theta. And for further simplification, we can say sin theta is sin theta by 2 cos theta by 2. And your 1 minus cos theta is 2 sin square theta by 2. So 2, 2 and 1 power of sin will cancel out. We will get minus cot theta by 2 as your simplest answer. Ta-da! Here we have x is equal to a cos t plus log tan x by 2. X and y both are function of t. So we have to differentiate both equation with respect to t. So from equation of x we will get dx by dt, which is equal to a differentiation of cos t will be minus sin t plus, to differentiate log tan t by 2 we have to consider box around the tan t by 2. So differentiation of log box will be 1 upon box into differentiation of box. So we just have to multiply differentiation of tan t by 2, which is simply sec square t by 2 into coefficient of our variable, which is 1 by 2. For further simplification, your minus sin t will be as it is, converts tan to t into sin by cos. So sin t by 2 upon cos t by 2 into sec square t by 2 can be rewrite as 1 upon cos square t by 2 into 1 by 2. So 1 power of cos will cancel out. We'll get 2 sin theta cos theta, which can be rewrite as 1 upon sin double the angle, or we can say t. Your a and minus sin t will be as it is. So we can take LCM. We'll get minus sin square t plus 1 upon sin t. 1 minus sin square t can be rewrite as cos square t upon sin t will be as it is. Now we should move to the equation of y. So we'll get dy by dt is equal to a differentiation of sin t will be cos t. So we are ready for dy by dx, in which your dy by dt will put in numerator upon your dx by dt will go in denominator. So your a and 1 power of cos will cancel out. We simply get sin t upon cos t. So your dy by dx is simply tan t. Ta-da! Here we have x is equal to a sec theta and y is equal to b tan theta. Both are function of theta. So first of all, differentiate both equation with respect to theta. So from equation of x, we will get dx by d theta is equal to a will be as it is. Differentiation of sec theta is sec theta into tan theta. Similarly, from equation of y, we will get dy by d theta is equal to b is constant. Differentiation of tan theta will be sec square theta. So we are ready to find out dy by dx, which is ratio of dy by d theta and dx by d theta. So in numerator, we have to put dy by d theta, and in denominator, we should put dx by d theta. So here 1 power of sec theta will cancel out. This b by a will be as it is, and let's convert sec and tan in terms of sine and cos. 1 power of sec theta can be converted into 1 upon cos theta, and this sine theta will be the ratio of sine theta upon cos theta. So your cos will cancel out, and finally you will get b by a 1 upon sine theta, or we can say cosec theta. Is your final answer. Ta-da! Here we have x is equal to a cos theta plus theta sin theta, and y is equal to a sin theta minus theta cos theta. X and y both are function of theta. So let's differentiate both function with respect to theta. So we'll get dx by d theta. On right hand side, your a is constant. We don't have to worry about it. Differentiation of cos theta is minus sin theta, plus in second term we have multiplication of theta and sin theta, so we have to apply multiplication rule. Your theta will be as it is. We have to differentiate sin theta cos theta, plus sin theta will be as it is. Differentiation of theta will be 1. Now for further simplification, we can say minus sin theta plus sin theta will cancel out, and we will get dx by d theta is equal to a theta cos theta. Now let's differentiate y with respect to theta. So we'll get dy by d theta is equal to a is constant. Differentiation of sin theta will be cos theta, minus in second term we have multiplication of theta and cos theta. Theta will be as it is. We have to differentiate cos theta, minus sin theta, minus cos theta will be as it is. We have to differentiate theta will be 1. So cos theta minus cos theta will cancel out. We will get a theta sin theta. So now we can find out dy by dx by taking ratio of dy by d theta and dx by d theta. In numerator, we have to put dy by d theta upon, in denominator, we have to put dx by d theta. So a theta theta will cancel out, and sin by cos is your tan theta. So ta-da! This is your final answer. Here we have x is equal to under root of a sin inverse t and y is equal to under root of a raised to cos inverse t. Sin inverse and cos inverse are complementary function of each other. So for simplification, let's multiply our equation number 1 and 2. So on left side we will get x into y, and on right side we will get under root of a raised to sin inverse t into a raised to cos inverse t. Our right side can be simplified as a raised to sin inverse t plus cos inverse t. For further simplification, you can say this sin inverse t plus cos inverse t is simply become pi by 2. So here we get x into y is equal to under root of a raised to pi by 2. Now let's differentiate our equation with respect to x. So on left side we have product of x and y. So we have to apply multiplication rule. X will be as it is, differentiation of y will be dy by dx plus your y will be as it is, differentiation of x will be 1 is equal to differentiation of right hand side is simply 0 because it is a purely constant term. So we can say your dy by dx is simply minus y upon x. Ta-da! This is your final answer.